be talking about our exciting new product, the PiezoStent, which is a result of our project to design and optimize a removable piezoelectric tracheal stent.
There are currently 4.9 million cases of tracheostenosis per year globally. So tracheostenosis is the narrowing of the trachea, and its primary treatment is resection of the trachea, but this can cause strictures. So other treatments for the stenosis or strictures are tracheostents, but these require invasive surgery and can cause risks to the patient. So we're proposing a tracheostent that is made out of a piezoelectric material, which means it can collapse or expand when a voltage is applied. So this would allow for easy placement and removal of the stent from the trachea or into the trachea, and it would also decrease the risk of complications. So our primary audience would be patients with tracheal injuries or diseases, as well as hospitals, and then our clients would be surgeons or investors.
So our approach to this is to first create a stent out of PVDF, and then we'll use different voltages to expand the stent to different morphologies. And then we'll coat the stent in silicone and have 3 leads that will be covered and that can be exposed when the stent is ready to be removed. And to apply the stent, it can be inserted via bronchoscopy, and it will be inserted using the traditional balloon method, which is a clinically accepted method, so it's safe for the patients. And when it is ready to be removed, a voltage can be applied to the leads and it can be taken out. And the charges needed to contract PVDF is 0.1 to 0.2 picocoulomb, so it's very safe for the patients.
The benefits of this approach are many, but mostly stem from the fact that no surgery will be needed to remove the stent. Therefore, it's less expensive in both time and surgical costs, and they can be deployed in places that have less access to surgeons who would be able to remove this, meaning that it would have a broad reach globally or in surgical deserts across the US. It would have all the benefits of hybrid stents, which includes having silicone on the outside, which is exceptionally biocompatible, and having the sturdiness of the metal interior stent. We found that the average hospital cost for people with tracheal injuries is $2,000 extra, which is attributed to a 1.1 day longer stay. Hopefully we could decrease that cost. And on top of that, the PVDF core that we would use costs about 1/10 of what nitinol costs, and that's what the traditional metal stents are made out of. The costs are a few. It is expensive and difficult to train piezoelectric materials for their uses. On top of that, like any stent, we have to worry about migration. And the cost of the PVDF is about 10 cents per stent. And we found that the average Medicare reimbursement for stenting as it is today is roughly $5,000. So that's the price range we want to stay in for the entire procedure.
So there are tracheal stents already on the market. The first to reach the market was released by Merit Medical. It's called the PiezoStent, which is right here. And then Boston Scientific followed them and released 2 stents to their product portfolio, the Dynamic Y stent and the Ultraflex stent system. These stents are very similar. The Aero and Ultraflex are the most similar. They are nitinol wires coated with silicone, and then the Dynamic Y stent is actually aluminum rings coated with PU. These stents are all intended for permanent deployment. It does require surgery to remove them, and so there's still that market need for a removable stent. Medtronic recently announced their idea for the concept of a knitted removable tracheal stent, which basically could unravel at the time of removal. There has been a feasibility study that was published, but nothing beyond that has happened in the last 1.5 years, meaning that there's still that need for a removable stent is still unmet. So where does our product come in? We propose a cost-effective and competitive tracheal stent that could revolutionize the treatment of tracheal stenosis.